Hello viewers, welcome to Quick Coder. My name is Tulsi. Today's topic is Introduction to Stacks in Java. In this video, we are going to discuss the basics of stacks and how to implement the stacks using arrays. Okay, so let's get started. Okay friends, now we are going to discuss about stacks. In Java, we already have inbuilt stack collection. Okay, without implementation of push operation, pop operation, we already have the inbuilt function, but inbuilt collection. But now I want to explain them also. Okay, I want to implement them that functions like push pop operations using array in Java. Okay, so before going to that implementation, I want to tell basics of stacks. So what is a stack? Is nothing but up to now we discussed about arrays or linked lists. Okay, I think we have discussed about these two topics, and these two have their own advantages and disadvantages. But coming to stacks, stacks are nothing but these are used in some real world applications also. Okay, like see here, for example, you're a software developer, and what you're doing is uh, in a software product, you are developing a software product, and in that what you're doing is the coding is over. Coding part is over. Now you want to deploy it. Deploy it. So after coding part is over, you want to deploy it. This is the first task you want to complete. But in middle, you have occurred some bugs here. There is some bug. Okay. To clear this bug, there is some process. So this is the second part we have encountered that there is a bug. So to clear this bug, there is some process you have to do where the bug is. Okay, you have to do that all the things. But in middle of this, you are going to lunch because you cannot do continuously. So you want to go to lunch in the middle. So this is the third task. So what will be first completed? The last come will first completed. So that is the main thing. Before last. Okay, so last inserted first output. Okay, see here, this is the last come function, but you're after completion of this lunch only, you're finishing this bug process, and then only you're completing this deployment process. Okay, so that is nothing but stacks. Stacks have many advantages. So in spite of this, we have many things here. Okay, LIFO. Okay, last in, first, last in, first out. That is about the stacks. So in stacks, we have some methods like push. So what is push? What is pop? What is peak? Okay, what is size? What is empty method? These all are methods with stacks. Okay, so these all are methods that in Java these are already implemented. But again, I want to implement them in front of you using arrays. Okay, so you can implement stacks using two things, using arrays and using linked lists. I think we already completed all the things about linked lists. So the work that I'm giving to you is please try to implement these stacks using linked lists. Okay, and after some days, I will make the video how to implement the stacks using linked list. But in this video, we are discussing how to implement them using arrays. Okay, or static. Okay, static means nothing but they're not dynamic, means they cannot shrink themselves or expand themselves. Expand or expanding and shrinking is not possible here. Because, for example, see this is an array. The one by one element is coming like 1, 2, 3, and we are creating array of size 5. We just inserted only 3 elements. So these two spaces, there is uh, more space to insert 2 more elements, but these are wasted. Or else, if I want to, I inserted 5 elements and I want to insert some other element 6. But there is no expansion because I created array of size only 5. So that is the reason I'm saying stack. You can also have dynamic. You can also have a dynamic representation. But in this video, I'm going the representation of stacks using arrays statically. Okay. Now during implementation, I will explain this all the methods. Okay. Now let's start coding. Okay, let's start implementing now. I created a main.java. In this main.java, I created an object of stack. So what is there in stack class? In stack class, I have, sorry, okay. So I have created a stack and top is equal to -1. So I want to explain you what is top here. Okay, see here. Okay, now let's continue. So first of all, I want to explain this what is top. For example, this is the array we have taken, which is of size 5. Okay, 0, 0, 1, 2, 3, 4. Okay, so this is the array. So always you think that stack is open at only one end, means at only one end only it can insert or delete the elements. It is closed at another end. It is only open at one end. So instead of doing like this, we can do like this. Okay, so stack. So this is the array. This is only open at one end. Now what is top is? Top will always pointing to -1 itself. Always pointing to -1. If top is equal to -1, then there is no element. You can say that. So what will happen in push function? In push function, what data is inserted? What happens here is, see, so if I want to push a data of 1, so what happens first is, first of all, I want to increment my top plus is equal to top plus 1, means this will be incremented to 0, and so st or stack, no, the name. So stack of top will be data. Okay, so at the 0th position, the data will be inserted. Like that. When some data is taken, you want to again. So my top is now 0. No? My top is now 0. My top is equal to 0. And again, what is happening here is, again you want to insert some other data like 2. Then what you are doing is you are incrementing the top plus 1, and now at the first position you are inserting the data, means at the first position you are inserting the data 2. Now my top is pointing to here, like that. 3, 4, 5, you inserted all the 5 elements. Now what is my top? My top will pointing to here. That is nothing but 0, 1, 2, 3, 4. My top will be 4 now. Okay, if or again you want to insert the data 6. So what will happen now? Again you want to write the corner cases also, means if my top here, if my top is equal to size -1, then the stack is full and you want to print like overflow. So overflow condition occur. So these are the two cases you should be handled. If my top is equal to size -1, overflow. Otherwise, you want to increment the top and stack of top is data. So that's it. That's it about this push function. So let me write that. So what is the first thing you want to do? You want to say like this. Okay. If my top is equal to size -1, if my top is equal to size -1, then I want to write like this: system dot out dot println like overflow. Okay, so like this will happen. Or else what you want to do, you want to increment the top plus is equal to 1, and at the stack of top you are giving the data. That's it. It's very easy to implement. Okay, okay, okay. So this is the total of this push operation. Now let's go into the pop operation. Okay. Now I want to explain the pop operation. Okay. So for example, this is my stack and I have inserted some elements, and here is my top. Top is nothing but 0, 1, 2. Top is my 2. So if my top is greater than -1, means if my top can be 0, 1, 2, like that, it can pop. So what can I do? I just want to return. Here what I want to do, return. Pop means nothing but the top element will be popped first. So return stack of top. Then I am decrementing my top is equal to top minus 1. Means again I am decrementing my top. This means my top will be pointing to here. Okay, again I can insert 3 more elements. Okay, or else what will happen? My top is pointing to minus 1 again here under flow, because if my top is equal to minus 1, there is no elements. So I just want to print underflow condition. Okay, let's implement this one also. So what is the first thing I want to do? My top is equal to minus 1. So if my top is equal to minus 1, okay, then I want to first of all print system.out.println it's under flow. Otherwise, again I am returning here because I want to return something. So return minus 1. Or else, what is the first thing? You can do like this. If I do like this, something like return stack of like top, and again doing top minus is equal to 1, this will get unreachable code, because after you return the stack of top, it will not go to the next line. So what I'm doing is get rid of this. First of all, I'm storing in a data variable, I'm storing stack of top, stack of top. Then I'm incrementing top minus is equal to 1. Instead of doing stack dot top, I'm just returning data. That's it. This is my pop conditions. Okay. Now what is peak? Peak is very similar to pop, but instead of decrementing top, we are just returning the top element. That's it. We are not popping out that. So the same code here we paste the same code, but we will not do top minus 1. Means instead of doing like this, we can just simply write return stack of top. That's it. We don't need to decrement the top because we are not deleting that. We are not popping out. Instead of writing under flow, we can write no elements. Okay, no elements. Now, what is size? See here, again I will explain. So how can we implement the size method is, for example, this is the stack we have, and we inserted 3 elements and my top is pointing to 2 because these are my indexes. So how can I say my size? Simply top plus 1, because I have 3 elements. This is 0 based indexing. I just want to say top minus 1. If there are no elements, what is my top? Top is equal to minus 1. So as there are no elements, minus 1 plus 1, 0. It is satisfied. So I can do like this. Just return top plus 1. That's it. Okay, and there is some other function, right? What is empty? What will do this function? Is empty means this very easy. If my top is equal to minus 1, then I can just return 2. It is saying that is empty or not. If my top is equal to minus 1, it is empty. Otherwise, it is not empty. False. Okay, how to show the elements? How to show the elements? Okay. So this is my stack, and there are some elements in this. Let me take. I'm inserting like this. For example, 3, 2, 1. Okay, so this is my top. If I want to show the elements, I want to show from the top. So what I will write here is, while my top is not equal to minus 1, I'm just doing print this stack of top, and then I will decrement my top minus is equal to 1. Or decrement my top, when my top is equal to minus 1, this while loop stops. Okay. Then there is also one corner case. If initially my top is equal to minus 1, no elements to print. Like I can do like this. System dot out dot printer no, or stack is empty. Otherwise, what can I do? Otherwise, else while my top is not equal to minus 1, just do like this. System dot print stack of top in spaces and top minus is equal to 1. That's it. I implemented all functions. Okay. Okay. Why it is showing error? Okay, sorry. There is no size initialized because this is my static size. Okay. So it's predefined. So if it is equal to 4. Okay. Okay, it is all done. Implemented push function, pop function, peek function, size function, exempty function, show function. Now what is there in okay, I push totally 1, 2, 3, 4, 5, 6 elements. So what will be the output is? Let me assume that what will be the output. So this is my stack of containing only size 5. Initially my top is equal to minus 1. Something is pushed. So here will be my top. Again 20 is pushed. Here will be my top. 14 is pushed. Here will be my top. 33 is pushed, here will be my top. 25 is pushed, here will be my top. But as okay, again 57 is pushing, it will return what we wrote in this, I think, overflow. It will print overflow and st.show means it will show like this 25, 33, 14, 22. But here we are doing some mistakes because here I am decrementing my top. So it's not a good thing, no? If here while in my show function I'm just decrementing my top will come to minus 1. So when I'm calling this st.pop, it will return stack is empty is true, there is no elements. It will print like that. So what I'm going to do here is instead of doing like this, what I want to do is I'm storing this top in some temporary variable. So my original top will be C. Now what here I will do is like int temporary top, t top is equal to top. Now instead of doing this t top, I'm just doing this. Instead of top, I'm just doing t top, temporary top. Okay. I will save this. Okay, again coming to here, there is one thing like underflow condition. It will print overflow condition, overflow, and pop element means 25 will be here, and this is popped out. Means my top will be here, and st.empty is it is empty? No, it will return false, and st.peak again it will return 33. Means what will be our expected output is overflow 25. Oh, sorry, not this is the overflow. This is the overflow. Okay, this will return like 25, 33, 40, 22. No? Like 25, 33, 14, 22, 25, false. 33 again show method means as 25 is popped out, I will get like this 33, 14, 22. Okay, let me erase all the remaining. Okay, now let me run the code. Is main.java. no errors. Java space main. Yes, it is giving overflow, and somewhere it is giving like array index out of stack line number 11. I think okay, I should keep this in else part, no? So just forgot to keep this part in the else part. Okay, now let me save this. Let me run again. Java space main dot java no errors Java space main. See here, overflow. Okay, it's correct. 25, 33, 14, 22. Okay, it is correct. Pop element is 25. The stack is empty false. Peak element is 33. And again my elements is 33, 14, 20. That's it. It's very easy to implement. Okay, so this that's it. That's it about this video. Thank you friends. Thank you for watching this video. The coming up video is detecting duplicate brackets of an expression in Java. So we should detect whether the duplicate brackets are there in expression or not. So this can be done using stacks. Okay, so that's it about this video. Subscribe to my channel Quick Coder to get notified for the further videos. Thank you. Thank you for watching.